From medicine, 2, 3. 3 medicine. All right. What else? Who feels they are not represented by computer science and medicine? What else? Okay. All right. I'll start from the back and come to the front. Yeah. Applied mathematics. One, or more than one. 2, 3, 4? 3. Okay. And what else?
Economist.
Economist, hello. And economist, just one economist? 2 economists. Good. Are you specialized, like health economist or something like that? Or, okay. Both of you. What was that? Agriculture. All right. Okay, so I'll put here economist, because if we start specializing it, the numbers are going to go down. And what else do we have? Yeah? Telecommunications, engineering. All right. And bioinformatics. Okay, so I'll just put here bioinformatics. 1. Telecommunications, engineering. 1. Is that all, do you think? Oh, sorry, yes. Information systems. Excellent. Right. Anyone else who feels they are not represented by CS, by computer science, medicine, applied maths, economics, bioinformatics, telecommunications engineering, and information systems? No, we covered everything. I don't see anyone who's doing business, because that would be the keystone. Because then I would just say, we already have the business in here. We already have the company in here. We've got all the people who have the knowledge about computer science and algorithms and all of that. We've got the people who know what is wrong with the people, what is wrong with the subject, which is the medicine. And then we've got so many other people who can help them and work in complementary ways. Health economics is a very important thing. And also, I mean, in this country, telecommunications, engineering, information systems, possibly always topical. I was very surprised, as I heard yesterday from other colleagues, that you've got such a huge coverage of 4G, over here, definitely more than where we are coming from. So let me tell you a little bit about our journey today. It's going to work both ways. It has been a learning journey for me, and I hope we're going to make it a pleasant learning journey for you. So we have a session this morning which is about applications of data science in health. We've got another session the afternoon which is about data visualization. And there is a small time slot on Thursday where we are talking about the health data scientist, let's say. So that is like adding another line here. And we're going to see what is different about that person, what is different about the environment they work in, what is different about why are they different from computer or not from computer science, and so on. So these are 3, let's say, waypoints, and they are linked with the same story. Okay? So this morning is about some applications in data science. Then in the afternoon, we are doing the health data visualization, but on the same subject, all right? On the same thread. And then we are talking on Thursday, where we are sort of wrapping up the whole thing. Okay, you get a little bit of background today, and by Thursday, we are all in tune about health data science. I showed you before There we go. So this is a this is a website, but really is all about bringing some of the resources we are going to use today at the same place. It describes the whole journey I told you before. So it has a little bit of a message so that you know a little bit about the background, about the facilitator, then what the workshop is about, and then focusing a little bit more on data visualization for good reason. We'll come to that. Then we've got the practical, and then we've got some useful links. So you are going to get access to this. But what I would like to sort of kickstart the day with is access to the internet is via the network DSA1. DSA01. The password is the same as yesterday. The capital DSA at NM 2017. This computer is connected to that network with this password, which I didn't change it from yesterday. So, all right. Yeah, that's gonna be challenging. So this is I'm just going to leave this up there. And we were contacted. So as I said before, this is a little bit, so you will get the background, all the scary background as well. Okay? So we were contacted some time ago about this event, for which I had no idea that it was already going strong for like 3 or 4 years, and it had already taken place in different places. This year was coming to Arusha in Tanzania. So imagine that you're sitting at a desk in Wales, in Swansea, and someone comes in and they say, what do you think about going in Tanzania in the Nelson Mandela Institute of Technology doing a sort of an overview for health data science? And so I said yes. But we had a little bit, there was a little bit of a mismatch in our motivation. So I thought, I'm going to go there, but it's a challenge for me to find out things about the area. And then if I'm coming to speak to you, in a way, there was no point to tell you things like the quality outcomes framework, how do you process the data that we have access to. You are operating in a different environment. So we started talking with Ms. Dina and Chira, the organizers, and we started asking what is happening in Africa in terms of data, in terms of understanding what is happening on the ground. And this is probably one of the first messages which is in the background. If you don't understand something, if you cannot measure something, you cannot change it. So you can have a big problem, whatever, in any domain, whether it's financial, whether it's health, whether it's whatever. If you cannot quantify it, if you cannot evaluate it, you cannot change it, right? So this was the this is in the back of our minds. So we started asking about data, and it transpired to great surprise. Hello. It transpired to a great pleasant surprise that almost all countries in Africa, almost all geographical regions, had some form of open data initiative. So Tanzania had its own, Kenya had its own, Nigeria had its own. As I said before, I'm not going to fall on the trap of trying to identify which one is the country, which one is the city. But yeah, I think that all of the regions that are mentioned here do have some representation on open data, which was great. All right, so let's look at Tanzania. Fine, exciting, this is great. You go on the website, it says there are 264 data sets. Great, where do you start now? You know? And you start scraping the thing, you start sort of scrubbing the surface, and you start getting to know the country before you set foot here. And after some of this searching, I came across the health survey. So I don't know if you know about the health survey that happened here, right? There was, in fact, let me see if we can very quickly just, there we go. So Tanzania, the demographic health survey. This one is 2004, 2005. I've used the 2010. So this is the thing, opendata.go.tz. It will keep you there for hours. It's so interesting. You just, this one and that one, and deaths and births, and what about this disease? What about that disease? It's incredible. It's like a playground. So you go into one of these, you download it, the 2010 health survey, which is the one I used, is something like 400 megabytes of CSV files. All right? It describes everything. Male, data about male, data about female, data about children, births, deaths, everything. So that was a little bit of a shock because it's like 456 megabytes. How do you shift? You know, you're on the clock. In July, you have to do a trip, which is like 20 hours, and go to Tanzania and present something. So we had to quickly see what can we do. So I went through the 2010 health survey, and I noticed that in the household data, what happens in the household data? Someone knocks on your door, they come in, they probably have some sort of electronic equipment, they start asking questions. How many people are living here? Where do you get your water from? And so on. That was the first bit that I found out about Tanzania. The CSV had 3,331 columns. Okay? The CSV I was looking at was 82 megabytes big. So 82 megabytes, right? A few thousand of rows and 3,300 and, sorry, about 10,000 rows and 3,331 columns. All right? I'm already tired, you know? What are we going to do now? Okay, so you shift through the 3,331 columns, and you see things that are repeated again and again and again and again. So one question seems to be having 20 possible responses. And that was when I found out that in Tanzania, a household might be composed, might not be in the classical, let's say, or the ones that I would have in mind, but there may be 2, 3, 4, 5, 6, 7 persons, 8, a large number, partially because part of the population is in a polygamous relationship. And this is a detail, maybe, or different for me, it would be a different thing, but also has an impact on what is happening when these people interact. So you get a little bit like a spark, something wrong, like a disease or something, and you can sort of guess that if we have this kind of social structure, then the disease is going to spread in a different way than if you had a different social structure with smaller family kernels. So trying to unpick all of these things from the CSV, I noticed that some of the columns were repeated. Some of the data were repeated in each of the rows. And these were data to do with the housing. Right? So everyone was asked the same questions. Where do you live? Where do you go to get your water? Where is your nearest health facility? What is your house made of? And so on. All right? These were duplicated. So if us three lived in the same household, I was asked, where do you live, blah, blah, blah. That data goes in. This person lives in the same household with me. The data is captured for them. This person lives in the same household. The data are captured for them. And so the idea was, all right, let's see the housing conditions. Let's see where and how does the population live, all right? And this is a little bit of an anecdote, all right? I went through the whole thing with my knowledge again, blah, 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 blah. I came back, I started talking to Dina and Chira, and they said, you know what? Over here, our households are organized in bomas. I thought, what is a boma? Okay, you see, I have no idea what is going on. And in some files, I think it is mentioned as boma. In some other files, it is mentioned as a cluster. So I wasn't sure what was going on there. And I'll just leave that as a note for you, because it will become important when we start looking into the data. Okay. So there are about 10,000 entries, approximately 10,000 entries in that file. They have a cluster identification and the household identification. And when you look at the household identification, because that's what almost there. Can I do this? Yes. All right. There we go. Okay. So these are the 20 out of the 3,331 attributes. I picked up 27. Okay, because I wanted to look at the household, but honestly, there are so many stories you can say out of just one file. Okay, stories, not made up stories, about what is happening in the country, the heartbeat of the country. So you see, every household has a cluster number and a household number. And then a number of other attributes. We're not going to look at them at the moment. So cluster number and household number. Household number was repeated. So I was thinking, well, okay, I can understand it being repeated for every person, but then how can it be repeated in different clusters? Right, let's go back and ask the people on the ground. It transpired that the household is unique within the cluster. Right. But then there was a separate discussion. In some people seem to be thinking that actually the cluster number and the household number can be repeated as well. In the end, what I did was to just keep the household number. Okay? And so I removed all the duplicates, and from the 10,000 rows, we went down to about 451. 451 unique houses. Unique houses, right? With these unique houses, then we have, so we have number of household members. How many people live there? Type of place of residence. Is it in the rural area or is it in the urban area? Very important field. Cluster altitude in meters. This was one of the things I wanted to look into, but it proved a little bit challenging. But I wasn't sure. You know, cluster altitude. Why do you want to know how high geographical altitude is the place? Okay, we'll come back to that. Source of drinking water. Time to get to the water source. Type of toilet facility. Now we are coming to the interesting things that are going to come back and bite us. Does it have electricity? Does the household have a radio? Does the household have a television? Does the household have a refrigerator? All right? Why are these things going to come back and bite us?
to use them to estimate the wealth.
Sorry?
You're going to use them to estimate the wealth.
Okay, so why is it danger? Why is it dangerous? Why is it a little bit problematic? Has electricity, has radio, has television, has refrigerator.
Taxation?
Sorry.
Taxation or billing?
Taxation or billing. Let's keep that in our mind. Let's keep that in the back of our mind. What could go wrong? Yeah?
Because all this one they need electricity. So
There we go. That's a hint. All right? No. Hold on. You will see what I mean when we get to that point. Because at some point I thought, it doesn't matter if you have, if you have electricity, you have radio. If you have electricity, you have refrigerator. No. And this is again very specific to this place. Okay? You can have a radio, but operate it on a solar power. All right? You see, you are laughing because you know, I don't know. And I am a few thousand kilometers away in Swansea. Anyway, right. Has this, has that, blah, blah, blah. Main floor material, main wall material, main roof material. For me, these were very, very interesting fields, okay? And we will come back to them, but these three things almost defined what you're going to come across. So you walk in an area, how many different types of houses might you find? Mind you, I'm not sure if it is possible to find similar data or similar information for the UK for this specific thing, the type of place you are living in. But for me, it was very, very impressive to find such detail in a data set. Has a landline telephone. Another great field, okay? You're all laughing, so I'm not going to go into this because we all know what is happening there. Does it share a toilet with other households? A lot of people, we said before, social conditions. Does it share a toilet? Okay? Type of cooking fuel. All right? This is the actual title. Anything done to water to make it safe to drink. All right? Number of households sharing the toilet. Does it have a paraffin lamp? Does it have an iron? Which is a bit like the previous thing. If you have electricity, you have... No. Main source of energy for lighting. And again, it doesn't mean that if you don't have electricity, you don't have lighting. All right? How far is the nearest marketplace in kilometers? How far is the nearest health facility? Right? And amidst this whole 3,331, you get two more fields, which are very interesting. One is the wealth index, and the other one is the wealth index factor score. The wealth index is very coarse. Poorest, poor, rich, richest, and maybe a couple of more characterizations. But whether you attach the label rich, richest, poor, poorest, is a little bit is independent, or rather it depends on the wealth index factor score. And that's a number. And I think that the top number is something close to 40,000, and that the lowest number is something close to minus 20,000 something. So this is the setting. And this is the setting pretty much in other data science tasks. Someone comes to you, they land a big data set on your desk, and they say, now make sense of this, okay? And tell us, what does it say? So the three things I am going to try and tell you from this little story, let's say, of us coming to Tanzania and talking to you. This exercise, let's call it exercise, contains three things. Number one is descriptive statistics, or trying to understand what is the data about. Remember, this is 10,000 rows by 3,300 attributes. It is impossible for a human being to go through that thing row by row, cell by cell, and get an idea what is happening in the population. And let me remind you here some of the things that Niels was talking about yesterday, where we link the human being, the data, and the computer. Where is the place of the computer? Where is the place of the human? Where is the place of the data? So that was the number one thing, and you will see why. So number one is descriptive. Number two is trying to make sense a little bit about the social structure. What is happening? How many, roughly, how many are the rich? How many are the richest? How many are the poorest? And what is happening in the middle? Another technique there, which is clustering. So descriptive stats, clustering, and finally, a little bit of modeling. I say a little bit of modeling, okay? Trying to understand, if I take all of these attributes, can I predict the wealth index factor score? Or in other words, if I look at the household, I can guess what is the condition of the persons living in that house. Right? So that was done in a straightforward way. We'll come to this, we'll come to the details if you like, but just to put the three headings together. This one's the one that's dying. Oh, there we go. Leave that there. Descriptive, clustering, modeling. So I'm going to walk you through this journey that I took to understand what is happening in Tanzania. The specifics, the details for this is not what I want you to get out of this. The message is the technique. Because, for example, some of the things that you're going to see for the descriptive stats in the beginning are universal. And in fact, it's the first thing that you would do when you're processing a data set. As I said before, 10,000 rows by 3,300 columns. It's impossible for a person to go through it cell by cell, row by row. Right. And as we said before, whether you are in agriculture, financials, bioinformatics, applied math, economist, when you get handed a data set, you need to understand what is happening in the data set. So let's see a little bit of this. So this is where we are. The heading is House Construction and Basic Urban Networks. I've got to admit, some of this was a bit ad hoc. So I would first look at the data, see what it says, and then group it together. So the grouping is a little bit ad hoc. This is the interesting bit, as I said to you before. Let's improve that a little bit. All right. On the left, on the labels, you see all the different combinations of households, all the different combinations of building types. The first one is the soil, the middle one is the walls, and the one on the right is the roof. If I remember correctly, there are two different types of bases, slabs, 4 different types or 8 different types of wall material and 4 different types of roof. So 2 times 8 times 4 are all the different houses you will come across in Tanzania. All the different types of houses. The place of residence is very important. So everything that you're going to see here is divided into rural and urban. I'm trying to understand how people live in the rural areas, how people live in the urban areas. Have you seen one of these diagrams before? Not this one that talks about houses. So have you seen and used the histogram before? We are all clear with the histogram. I don't need to go into details and everything, okay? It's a very simple but very powerful tool. It tells you how many of a specific category, how many items of a specific category are there in your data set. The only additional thing I have done here is I have normalized it to the maximum. So you can see that in the rural areas, the most common way, the most common building, the most common way of building houses is earth, sand, dung as the base, baked bricks, and an iron sheets on the top. Yeah?
Yes,
For me? Sorry?
Sorry.
Yes?
Request if we can use, we can take the Ethernet switch on the access point, we swap.
Yeah,
because
okay.
we're having internet problems there. And
That's
then
fine.
I'll request my colleague.
That's fine. You have to find out, okay? 10,000 rows, 3,000 columns. You may have network, you may not have network. Maybe this, maybe that. So commando style, be prepared for everything, all right? Everything is, oops. Everything is in USB disks and everything. If anything goes down, we can make up for it. Right, let's get back to this thing. The most common rural type of house is that one. The most common urban type of house is this one. Cement slab, sun-dried bricks, iron sheets. Did I get it right? That's my question, because I still don't know. I came here, I landed in Nairobi, landed in Arusha airport, and I have seen Arusha and surrounding areas in the Nelson Mandela. As far as I can tell, I saw echoes of this diagram around me. Well, you guys are on the ground. Did I get it right? And please tell me if I get it wrong, because that's my bit of learning, all right? All right, so earth, sand, dung. You can see that earth, sand, and dung features a lot in the first few rows. By the way, this diagram is longer. It keeps going. There are more categories, there are more combinations, but I only selected the top 20. So here is a question. How do you select? Why did you go for the top 20? Why top 20 and not top 10? Why the top 5? So my question to you is, you find yourself in a scenario where you're thinking, look, this thing goes on forever. But I want to capture the most essential parts. How do you do it? How do you decide? So let's just don't worry about wrong and right. That's not our point here. It's about dealing with this problem. So we have a problem. How do you select? Why should we stop at 20 categories? Any ideas? Just don't worry. Yeah? Oh, sorry. Okay, interested in the variations?
Yeah, so if there are lots of variations in something and others it's maybe very little variations. You're interested in finding out why the variations may be there. It's more interesting.
Okay.
I would say significance to the maximum value of,
Oops.
basically zero variation.
So we've got variation here. What was the other idea?
Well, it's zero variation, but it's a different form. I'm just saying that it's, you could consider the maximum, the range of the maximum.
Okay.
Yeah. The maximum value. And
Okay.
the minimum value at some point. So it's a significance level we're looking at.
All right, so both answers looking at the range, maybe. What is your maximum? What is your minimum? Try to see what's happening in the middle. Try to show a representative range. Is that what the, okay? Try to show a representative range. Any other ideas? Don't worry about being right or wrong. I don't care. Yeah?
We'd be only interested in what is most common.
What is most common?
Yes.
We'll put here range, most common. Right? So let me see if I can put, yeah.
And then it also depends on the target of your what you're trying to do.
In what sense?
Okay, you could narrow the selected value based on the focus of your search.
Okay.
Yeah.
So what you're saying is, this is important for me, then I just want to focus on this one.
Yeah.
All right. So let's put here context, which is also very important. So let me see if I can, if what I did sort of encompasses these things. What are all of these events? What do we expect them to add up to? All of these different categories that they go on forever, they describe our data set. If you start adding the percentages, 0.6, 0.14, 5, 0.12, blah, 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 they all add up to They all add up to 1. All the different eventualities we might find in our data set. So here is a thing that we can do. We can say, why don't I select the first few entries that add up to 50% or 90% of the variation accounted into the data set? Because from then onwards, it doesn't really matter. The most common house you're going to come across is that one. What does that mean? It means that it has a huge number of entries into your file. Let's keep that in our mind, because when we are then going to start drawing conclusions, we have to understand what are conclusions based on. All right? This file labeled itself as Tanzania households. But the majority, okay, is a huge number of these entries are coming from rural areas. So if you start drawing conclusions, because they dominate the file, this is going to be all about the rural areas. All right? Keep that in mind. This is a powerful tool. It can tell you a lot of things about your... So, let's capture that in a bullet point. Yes? Sorry, so yeah, it's just capturing. We're going to take pictures of this, and you're going to have everything I write here. But for the moment, what it says here is select the number of bins that account for 50 or 90% of the total. And a bin is, of course, one of these bars. Okay? How are we doing so far? Okay? So, all right. This is the thing. You land at this place, this is what you're going to find. Another thing that is important here is the way that these curves diminish. Now, if you notice this one, it vanishes very quickly, which means that there are probably one or two dominating categories on top. Okay, so in the urban area, the thing that dominates is cement, sun-dried bricks, iron sheets, maybe earth sand, dung, sun-dried bricks, and grass thatch mud. And then things are going down very quickly. Whereas up there is a different story. You sort of have plateaus, which means that you have a set of people living in some conditions, another set living in a little bit different conditions, another set living in a little bit of different conditions. It's the difference between going down like this and the difference between going down like that. Something is happening there, something is happening there, something is happening there, and the rest, kind of thing, okay? Whereas with this curve, the solid one, more or less you just expect to see one thing dominating, okay? Right. Just off the top of my head, some of these differences I couldn't very much understand them, because these ones, if you notice, they've got earth, sand, dung as a basis. Then you've got cement, stones, or timber for the walls. And then on the top, you still have grass, thatch, mud. Okay? It's a little bit like it's the same house, but different material. So I wasn't sure what was going on there. So this took a little bit of time. Let's see, number 2. Electricity. Who has electricity? If you are in the rural areas, almost no one has electricity. All right? Well, except that tiny little sliver down there. If you are in the urban areas, almost no one has electricity. Again, which that was a little bit, you know, about 20-something% seem to be having electricity. Did I get it right? How do you feel about this? It depends. So let me I like this. We are now going to start saying, well, hold on a minute, Mr. I came out of Tanzania, all right? So let's say that this is Arusha. And the outer circle represents the whole surface area of Arusha, right? What this says is that maybe there is a tiny small percentage of the population or the households that do have some electricity, and as you are going away towards the rural areas, then that thing is falling down, is diminishing. So it's a little bit like a transition between urban and rural areas, but still in the urban areas. So we'll put an asterisk there. Maybe I got it right, maybe I got it wrong. I got it wrong. Now that we know that I got it wrong, we have to understand why did I get it wrong, and we have to see what is the truth in this. All right. So let's keep this as a task for the practical. All right.
Maybe I would say that
Yeah.
depends on how those who did the survey defined urban.
Defined
Depends on how urban area was defined.
how the urban area was defined.
Yes.
There are that's definitely, that is a great observation, because again, it's about context, right? How was this done? How was it captured? What was the interest? And all of this. There are two reports. One is in the World Health Bank, World of Data Bank, something like this. I've got the link. One was there, and the other one was on the Tanzanian Open Data, or the Statistics Service of Tanzania. The reports go on for pages and pages, and they probably do define at some point what is an urban area and what is a rural area. So, all right, I like this. This is our first disagreement. Let's put it here. All right. Time to get to the water source. We will come back to the numbers in a minute. Okay? Time to get to the water source in minutes. Now, I just used the time to get to the water source. There are also questions about how do you get to the water source? All right? And the answers there are, again, huge variety. You walk, you take the bus, you take the moped, you take the car, you take, what was it? The bicycle as well, all sorts of things. But the majority of the population seem to have answered that they live within about an hour of a water source. Yes, no? Mostly yes. Okay, be a bit good with me, okay? I mean, be a bit lenient. All right? So, and then, of course, again, we've got these bars coming down, and then we've got another spike there, and that one. Now, when you split it, this is the rural areas, this is the urban areas. Notice that the top is different. What is happening in the... So question number one, or rather, observation number one. Note that this is the sum of this and that. Are we clear with that? Okay? So when you see a number here, and when you see a maximum here, you have to understand where the maximum is coming from. All right? Over there, we just see it falls down, and then we have a few modes there. Over here, we see that it falls down, and we have a few modes there. But in the urban, it seems to be a different story. I've got a mode there, then I've got another mode there. Then I've got another mode there. and so on. By the way, the survey for some entries was not specific. It was saying, well, 99 minutes or 500 and something minutes or more. So there might be people that have to travel a huge distance to get to the water source, okay? But we don't know. They're very few, but still, that's the sort of resolution we're working. So our sample is there. And our sample here is there, maybe about 280 minutes. And this one goes up to there. So maybe predictably enough, rural areas you get some very high values, whereas in the urban areas, your maximum is within 200, 300 minutes. Why do we have these modes in the urban area? Let's keep that in mind. Let's keep that. What are the conditions where I can find people preferring to go to this source and then preferring to go to that source and so on? Because that's what it's saying to us here, that the most common, that's 100, that's 50. This is 25. So we see a mode less than 25 and a mode between 25 and half an hour. It's a little bit like most people live very close, and the next one is people living in a specific distance from a water source, and so on. Can you think of a way, it's a bit like a riddle. Well, if this is true and that is true, then that must be true. Why are these modes emerging? Okay, let's keep that in mind. Now, this one was another interesting. How do you get your water? How do you get water to the household? How is the household supplied with water? Bottled water. These are all the responses, by the way. Bottled water. Cart with a small tank. Neighbor's borehole. Neighbor's open well. Neighbor's tap. Open public well. Piped into the dwelling. Piped into a yard plot. Protected public well. Protected well in the dwelling. Public tap or a standpipe. Any combination or any response that involves rivers, dams, streams, canals, all of these things, spring and a tanker truck. All the different ways that you can get your water. Remember what we said before. The file, the data that you see is this picture overall. But it's a different story in the rural area and a different story in the urban area. Okay? And then when you start looking at so this bar is this bar plus this bar. No, hold on. We will have a look at it when we go to the code. So let's go back to okay. So in the rural area, your most common thing is an irrigation channel. And the next most, rural area. And the next most common thing is a standpipe. And the next most common thing is an open public well. Did I get it right? All right? In the urban area, the story is different. Your most common thing is a neighbor's tap. The next most common thing is a spring. The next most common thing is an open public well, and then a standpipe. Again, this is the urban area, right? Is that yes or no? Did he get it right? Did he get it wrong? Yes?
Yeah, I was wondering, there is nothing like tap, but there's neighbor's tap. So there's tap.
Neighbor's tap is there, but that is the actual label that was in there. That was there in the data.
So if I have, if I'm the neighbor, I'm doing the tap.
Exactly. That's the kind of thing I didn't think about. Then if one household has responded neighbor's tap, another household should have responded piped into dwelling. Piped into the dwelling. But I think that it's going to be very challenging for us to do the sums and just see who said what and who responded what. But let's keep the story that there's a different landscape in the rural areas and in the urban areas, especially when it comes to water. Where are we? Okay, I like this. Let's get to the interesting bits. This was the thing where you say, okay, when you get your water, do you do anything to it before you drink it? All right? What do you think? We're going to see. So this is the overall. Do you do something to the water before you drink it? No, the majority. And yes, over there. Any thoughts about this? I can tell you, this started a huge discussion on what is happening here. All right? And this is the curse of playing around with your work at the last minute when you get an empty graph. But what this is water treatment, what this shows is the water treatment by household. Now, remember that we had this problem, that what I said in the beginning, that is it the cluster and the household, or is it the household on its own? In the end, after discussing and trying to understand how this thing has been built, I decided to go with a household. So I just said unique household, and that's what you see here. I know, but this is a problem. It's not that this is the answer. So what we see here is water treatment requirement by type of household. So what this diagram should show is what is happening. If you are in the urban areas and the rural areas, do you treat your water? But this one, but if I remember correctly from the last time I ran it, it was that in the rural areas, the water is not treated, but in the urban areas, it is. So in the urban areas, it is treated more than the rural areas. And I can tell you this bit started, is this right? So in the city, you are expected to maybe treat the water more than when you are in the rural areas. The responses to what do you do to treat the water before you drink it were, again, let it set, sieve it, boil it, solar sanitation, and a number of other things. But then we started asking ourselves, hold on, is this because in the rural areas the water is cleaner and in the urban areas is not? Is that the right thing? And I like this. This is gonna be great. The other view was that in the rural areas, maybe people don't know that they have to treat the water before they drink it. What I thought is the first one, not the second one. I think that people understand very well what happens when you drink water which is not clean. And They have been living in this land for a very long time to know what's going on with the water. But it still remains a question. So what do you think? Why is it treated more in the urban areas?
Maybe the urban areas water
They wouldn't be contaminated.
contaminated in urban.
Oh, they are contaminated.
So
Do we have an indication why there might be more contamination in the urban areas?
even the source of water where it comes from sometimes
So, not a very pleasant place to live, and especially for water, the cities, right? Whereas if you are in the urban areas, you've got more chances to find clean water. Is that what you're saying? Shall we go with this? You're divided. Some people say yes, some people say no. Yeah,
I think also depends on the sources of water.
it depends on the source.
Yeah, I think some sources are really clean.
That is a very good idea. So I should have done, I should have break it down by source. So some sources might be cleaner
Yeah.
than others. Right. That's very interesting. All right. It's a playground. It's a playground. Yeah.
It's also in urban areas. We have more formal approaches to the supply of water and sewerage.
Yeah.
And in that formal setting, the treatment of water is done by the water and sewage companies, not even necessarily the individuals themselves.
So what you're saying is that the choice of whether or not there's going to be sanitation is not up to you.
In an urban area,
Yeah.
that's why it's urban. That
Right.
service is available. But
Right.
in some rural areas, you don't have piped water, for example.
Yeah.
And when it's piped, ordinarily it will be treated before distribution.
So, I mean, look at that. That's just a simple. Let me get this out of the way because it's empty. So, just by looking at the breakdown of different types of water sources, this is a story on its own. All right. This is you have to. It's a brain teaser. Why is it like this? And combine the data from the ground, which is what you guys know. I have no idea about this. I'm running the numbers thousands of kilometers away. I sort of make sense, but then you need to know what is happening on the ground as well. Good, good, good. We are both learning, I hope. Let's see what is happening here. Well, I see what is happening here. I may have got the labels wrong. This is the availability of a landline telephone, which, okay, this reminds me something else. I don't know, you probably have seen it from your experience. No data set is perfect, all right? And this data set is very good, but it's not perfect. There are two types of answers which I don't know how to categorize. One is 9, and the other one is 99. So this is yes, no, 9.
9 is still 4, I don't know.
Is it?
9 is still 4 missing there. It depends.
There you go. What I did with electricity was to go and see, when you have a 9 on the has electricity, do you have a refrigerator or a television? Because a refrigerator and a television are a high load. You can't put, maybe you can put a small television on a solar, but not a refrigerator. If it's a refrigerator, if it's not a refrigerator that you put in a camper van that operates on an inverter or whatever, then okay. So the 9 seemed to be the yes. in that case? Do you have electricity? If you have a refrigerator, you have electricity, kind of thing. But I take your point. It seems to be, I don't know if you have experience with working with this data. And okay, so this is great. 9 is, I don't know. 99 is missing data. Great. $99 missing data. All right? So this is the 9. If we bring this in that, if we shift this a little bit to the right, we see that the majority of the population don't have a landline, and the situation being a little bit better in the urban areas. So more chances to find a landline in the urban areas. Yes, no? I think we established that earlier. What do we have here? Now we're getting to the difficult bit. Do you share a toilet? Share a toilet with other households? That's the question. If you're in the rural area, it's a no. If you're in the urban area, it's a yes. It's very important for me. Did I get this right? Is this right? No. Not entirely. Not in. Oh, is this right? So in the rural areas is a no. In the urban areas, more of them is yes. So in the rural areas, you seem to not be sharing the toilet. In the urban areas, you seem to be sharing the toilet. Not you, the population, right? That is true. I can accept some wrong, you know, but not all of it. Anyway, all right? No, that's not for you. That's my judgment for myself. I'm beating me. Okay, right. And this is where we're coming back to some of the things that your colleagues were saying before, because this will probably be more apparent. If you are sharing if the household does share the toilet with another household, how many does it share it? The majority is 2, with 2 other households. 3, 4, 5. There are some that even share a toilet with 9 others. All right, 9 others. That's a very small population, very small percentage, but still a possibility. And this one is 10 or more. Right? 10 or more. Okay? All right. Now, do I have it? Do I have it here? Do I have it here? Yes. Right. Do you share a toilet? Yes, no. If you share a toilet, with how many other households do you share the toilet? By the way, what type of toilet? So when you have to go, where do you go? No, hold on. $99, all right? No, missing data. Flush to the pit latrine, flush to a septic tank, no facility bush filled. Other. What other? No, seriously. All right? Pit latrine, okay. Septic tank, all right. Bush filled, okay. Pit latrine, ventilated, improved pit. I really like this, VIP. This is what I'm reading now. Wherever I see VIP, I'm reading ventilated, improved pit, all right? Pit latrine with a slab. Gets better. Pit latrine without a slab. With slab, without slab. Oh, disaster averted. Okay. So these are our choices here. Pit latrine without a slab seems to be the most like famous, the most common choice, or the most common way, but it's a different story in the rural area and in the urban area. So in the urban area, you get this one, and the next one is flush to a pit latrine. But in the rural area, you still get the pit latrine without a slab, but the other one is, you just go in the field, man. We've got all this field, which is incredible. I mean, is probably, no, I understand why you're laughing, but you have to also consider the thing that this is the most natural choice, kind of thing. And because all the animals do it, all right? And the animals know, okay? And the animals know where to go to sleep, they know where to go to drink the water, they know where, they don't need us to tell them, and they don't need to tell us how we're going to do it. So this was again the kind of thing where you're saying, well, if they are sharing, if households share toilets, how do they do it? If you share a toilet, that's the type of toilet you share, the most common type. So we covered that thing. You see, what we're doing is you put the household in the middle, and you're saying, where do you get your water from? That's input. Where does your sewage go? That's output. Where do you get, we're about to see this, we're coming to the end of the torture, of the lecture. Okay, so, and so on. By the way, if you have one response from the other, please let me know, because what other? You know, what is other? There you go. What is that? Flying. Flying toilet. You mean like the chemical one? No? What is a flying toilet? A plastic bag. That's a very good name for a plastic bag, man. Flying toilet. Okay. No, look, that you you are improving it. It's not only that it's a bag, but you can throw it away. That's the flying bit. I was slow. Sorry. Slow to get that. One more reason to keep the windows closed when we are in the car. Right. Yes? Yeah?
How would you capture households which would have both? Probably they have a latrine and also have
The short answer is I don't know. There was only one field in the dataset. And it said, what type of toilet does the household have? And there was only one field. So I think they would capture the most common. If you have two options, which one is the one you're most frequently using? And I think that would be reasonable as an assumption. But yeah, this is another thing. You may have more than, what do? Maybe you should capture both. Okay. Living conditions. I've just called it living conditions. Number of household members. Right? 1 all the way to 15. Very few people 15 people living in the same household. 15 in the same household. The most common is 4. And then falling. Have you seen this distribution before? What does it look like? Normal. I think it's leaning a little bit, so maybe a bit Poisson as well in there. I don't think it's entirely normal, you know, but you see, this is the overall, but this is when you split it into rural and urban areas. So can we spot what's going on there? What is going on in the urban areas versus the rural areas? Zigzag. Yes, zigzag, but what does it mean? So you see what is happening. This is the rural area. Most common remains the answer 4. That's 4. That's 1. Not many people live on their own in the rural areas. But in the urban areas, you have a higher compared to the maximum, right? If you compare this to that and this to that, there's a higher proportion of people living on their own in the city. Who are these lonely people? But it's still, the question remains. What students? Hello? Students, bachelors, like professionals, working professionals. They go to the city, they live on their own probably, they have a job, all right? And similarly, we get some of these modes completely disappearing. You don't see a household which has, say, 7 people in the city. Or you don't see, which again might come back to what sort of provisions are there for housing. Maybe there are no houses that can take, say, 7 people. So it's difficult to move a large family. And these two, the following two are a bit similar. This is number of household members. This is how far to your nearest facility. Sorry, to your nearest health facility. How far to your nearest health facility? Yes, and the distance is in kilometers. Which again is very encouraging to see that the majority of the population lives very close to a health facility, right? And then we've got something happening there and something happening there. And again, something happening there and something happening there. And then in the urban environment, very different. And how far to the nearest marketplace? The overall, how far to the nearest marketplace, again, in kilometers. All right? Rural areas, urban areas, different stories. Rural areas, if you see here, that's 50 kilometers, that's something like 25. And that's like the most common thing. But in the urban areas, next door, just to go to the market. All right? So you see, the philosophy here was put the house in the middle. Where do you get water? Where does your sewage go? How far to your nearest health facility? This is going to be challenging. How far to your nearest marketplace? How many people living in the house? And with this tiny little sort of treasure map, you get an idea what you're going to find in Tanzania. You get an idea how things are looking like. So did we cover everything? Of course, I'm not going to go into the sewage and the pits and the things. Right. How is it going so far? All right? I hope you're getting the messages here. The message is understand what's happening in a data set, in a very big data set. You're using a very simple tool, the histogram. But your investigation is driven by questions and is driven by what is happening out there. I'm trying to understand something. It's not only about the histogram. It's not because if you just focus on that, you might get the numbers wrong. I got the numbers wrong by ignoring what is happening on the ground. Right. Let's move now to our second tool. We just finished with descriptive. Right. Now I know what is in the data set. I have an appreciation about the households. What I'm going to do now is I'm going to say how many unique households are there. All right? I live in a house and it's got a specific profile. So I live in a household that has a specific profile. It gets its water from somewhere, the sewage goes somewhere else, time to the marketplace is that much, time to the nearest health facility is that much. There are other people that are in the same type of living conditions as me. I may be living in Arusha, but they may be living in Dodoma or in Zanzibar. We live in the same conditions. How do we group all these things together? Because as you saw here, which was our first diagram, you have all these different ways to build. You have all these different ways to live. But maybe there are 5 types of living, 6 types of living. Out of the 451, we can put them into groups. All right? My thinking here was to say, is it possible to use this data to discover the social structure? So you, like a class system, middle class, upper class, lower class, and so on, okay? People who are very poor, people who are in the middle, people who are very rich, right? So this is where we are coming to clustering. Ignore this. I'll come back to this. So, what is happening with clustering? Have you seen clustering before? How many of us have seen clustering before? How many of us have used clustering? Used it and, okay, all right. So bear with me, I'll do like a very quick introduction about clustering, okay? Now, if I put all of these numbers that I showed you before, one next to the other, some of them, naturally, are going to be grouped together, okay? Consider households. How many people live in a household? How many responses you get where there is a cement base, iron sheets on the top, and so on? The point about clustering is to find an automatic way to group together the similar households. And you do this, and the key thing to do this is the concept of distance. It's a very simple concept, but honestly, there are books written just on the topic of distance. Okay? If you have 2 points, A and B, then you can estimate the distance between them. All right? If I know the x and y, so this is at 1, 1, and this is at 4, 3. Do we all know how to find the distance between these 2 points? Euclidean distance. All right? D is the distance between these two. And D is 1 minus 4, 1 minus 3. That's going to be the length of that line. But in our case, we don't have measurements. I'm not trying to find the distance between that corner and that corner. What I'm trying to find is the distance between ways of living. So instead of considering this corner being at 0.0 meters and that corner being at 5.5 meters, what I'm saying is this wall is going to be how many people are there in the household. And this wall is going to be the distance to the nearest health facility, right? Number of people in the household, distance to the nearest facility. Where am I now? This is 0, by the way. This corner is 0, okay? Number of people in a household, distance to the health facility. Few people close to the facility. If I'm here, more people, larger distance, more people away from the... Now, thank you. Now, if we start asking these people who live in these conditions to come into the room and just tell them, I want you to stand in this, where are you in this wall? This is 0, this is 15 down there. Well, in our house, we've got 4 people, so I'm going to stand here. And how far away are you from the nearest health facility? This is 0, this is 200 kilometers, about 100. Okay, so if you are 100, you're in the middle. One person comes here. Ask another person. They come in, they stand somewhere. Another person comes in, they have to stand in the same place as I am because they live in exactly the same place. So I put them on my, okay, you pile them up. And they keep coming in, 400 people, 500 people, they keep coming in. The room is not going to be filled because we are saying to these people, I want you to go to a specific place. So the people who are coming in and you say, go to the position in the room that is in your living condition, they bunch together. Similar living conditions bunch together. In our case, we don't have a room that has length, width, and height. In our case, we have a room which has 27 dimensions. Length, width, height, another length, another width, another dimension. I'm not going to go too far into dimensions because we're going to cover them in visualization as well. But what I'm going to say at the moment is that there is a mathematical way that you can ensure that these 27 dimensions are vertical to each other. One dimension, another dimension, vertical. Why do you want it vertical? Because when I have movement here, I don't want it to affect movement there. Third dimension. Fourth dimension. It's difficult for us to visualize 4 dimensions, but it's very easy for the mathematics. Because in the mathematics, the criterion is if the vectors are orthogonal, then you have a space. And in the mathematics, and in the mathematical world, you can create 4, 5, 6, 7, 8, 10 vectors that are orthogonal to each other. So in our case, we've got like 27 dimensions. A room with 27 dimensions that we ask people to come in and go and position themselves to how many people live in the household, how far away from the health facility, how far away are you from a market facility, where do you go when you have to go, where do you treat your water, how do you treat your water, all of these things. And this space fills up. That's how we can now, hello?
Can I ask a quick question?
All right.
Who would like
I thought you were going to ask me. Okay.
Yeah, no, just in general. For 20,000 shilling. Okay, so hands are up and down. Or $8. So if you want a SIM, we're going to have them brought on site. So a SIM card for data. for 12 gigabytes of data, Tanzanian SIM card. Yeah. So 1, 2, 3. Oh, whoa. 20,000 shilling. Okay. So hands up. Put your hand way up, or else I won't get the count right, because she's going to bring the exact number. That's too low. You only want half a SIM card. Hand all the way up. Hands up if you want. So with the one there, yeah. 1, 2, 3, 4, 5. You want one? That's like 6, 7, 8, 9, 10. 10. Did I get it? Do that second. Wait, was that a late hand? 11. Okay. So 20,000 shillings. Is that? Whoa! I can't hear that. What pump area? Is it Vodafone? Mintel or something? I wonder what it is. Pump? What is it? Which one? Vodafone. No. It's just one person coming on site.
No, the carrier.
The carrier, it's not Vodafone, no. I don't know, it's Mintel, it's just whatever carrier they call it. 12 gigabytes, 20,000. Okay. 11.
All right.
Was it 11? Okay, 11. Thanks, sorry.
All right, no problem. Okay. Right. So these cases bunch together. Why do they bunch together? Because similar living conditions, they have similar numbers, they bunch together. Now what we do, there are many ways that you can find these bunches. Many ways. This one is a very straightforward one. So what do? This is called hierarchical clustering. The objective is to find how many bunches you have in this room. Okay, so how do you do it with hierarchical clustering? You start down here. Each one of the lines is one case, is one household. So this line now has about 451 households. This line has 451 cases, right? We start with 451 clusters. Every household belongs to a cluster. Imagine this space having 500 people, one crammed on top of the other. Some spaces are empty. I can walk between them. There are piles of people here, piles of people there, and so on. So what do? You go to the two closest ones and you group them. And you say, that's a cluster now. 2 becomes 1. You find the two closest ones and you group them together. Then you do it again. You now find the two pairs that are closest and you group them. And you do it again. You now find the 4 quadruple points, and you group them together. And again, and again, and again, and again, until up here, you have your whole data set. One cluster that encompasses the whole data set. 451 clusters down here, each item being a cluster. In the intermediate and in the intermediate levels, you've got the groupings. What this shows you is the distance. So when you see this vertical line, this group happened at that distance, about 100. Right? Are we clear with that? Okay. So here is what is happening. This is the big cluster. This one breaks down to that one and that one, and this one breaks down to this one. In social theory, I've got a link in there anyway, but we have the standard lower, middle, upper class division. I have to say, it's a little bit, you put people into boxes now, right? But from the point of view of studying society, it's a tool, okay? I need to know how many people are there in the lower class, in the middle class, and in the upper class. And it is connected to their way of living. So if we do the clustering, the hierarchical clustering, and then we say, okay, give me 3 clusters now, okay? And we see that, and these are the data here, we see that we have a tiny little group there, a tiny little group there, and a middle class, which is huge. So we've got very few people that are maybe at the poorest conditions, very few people that are maybe in the richest conditions, and a very wide distribution in the middle. It's a coarse distinction, all right? But at this level, it will do. Now, when I went in there and I looked at some of these things, it's impressive that when you look at the data, the house type, the electricity response, the how far you live from the marketplace, how far you live, they are bunched together. So you get like the poorest, the time to the health facility the distance to the health facility is like, I don't know, 40 kilometers, 50 kilometers. In the richest case, it's the other way around. It's like very, 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 very near. And having done this, we are now coming to the prediction. Sorry, are we clear with the clustering? All right? The key bit is to understand what is happening with this piling up of points that are similar. And then how do I pick out those little piles? That's the thing with that's automatically. So that's the thing with the clustering.
What do you call this graph?
This is a dendrogram. All right? Dendro for tree. Right. Okay. Oh, worse. Stay. Okay. So now we are going to do another. We're going to do another little exercise. The question now is, given these attributes, can I predict how rich or poor is a person? Right? Just by looking at where you're living. Or not where you're living, what are the living conditions? All right? Again, this is scary because you may get it wrong. Let's see. So this is the third bit in our journey and final. Where we are going to the modeling. Have you all seen or do you all know what is a scatter plot? All right? Scatter plot, very similar to what we just described with the room. And have you all done at least a best line fit? Best line fit? Okay, what happens in the best line fit? I get points. Again, we don't care about space here. Yeah, it's the last thing. Okay, so we have our space here, but instead of just saying these are just numbers, we put our features there. So we still have a scatter plot which is 27 dimensions big. All right. In the best line fit, you use least squares to find the line that leaves all of the points equally dissatisfied, equally away from the line. But the line is summarizing all of these points. So the line is telling you where is it, more or less, where are you likely to find these points. And it establishes a relationship between this quantity, whatever it is, and this quantity. Yeah. We are finishing.
Okay,
Should we have finished 2 days ago? or not?
Yeah, tea is ready. So.
Tea is ready. Okay, tea is ready. So, what do you do? In our case, this is a fancy best line fit. Let's call it like this. What happens here, where if I know the x, I can then work out the y. If you know the x, you work out the y. In this case, what we do is, if you know 26 attributes, you can predict the 27th. Okay? And what it gives us is this. This is the strength of the attribute, and this is the attribute. That's the positive, that's the negative. Source energy light is electricity. If the household has electricity for lighting, okay, then it's got very good chances of being in the upper class. Followed by toilet facility is flush to pit latrine. Followed by water sources piped into dwelling. Followed by has television, has iron. Toilet facility, pit latrine, our favorite one, VIP, or my favorite one. Has a paraffin lamp. Main floor material is cement. And going down and down and down until you are somewhere here. Water source is cartwheel with small tank. It's kind of significant, but it is not very strong contribution. Essentially, if you look at the household, if the source of lighting is electricity and the toilet facility is flush to pit latrine and the water source is piped into the dwelling, you have a good indication if it's a poor or a rich house. And at the same time, the upper part is what contributes to the positive. Positive is towards the rich. The lower part is what contributes to the negative. Negative is the poorest sort of bit. And main floor material is earth. So main floor material is earth, boom, accounts for this much of the index. Water source is the neighbor's open well. Water source is an open public well. Water source is spring. So you can see the floor material and then the water source and then the wall material of the house. Then again the water source and then residence is rural. Water source is the neighbor's tap. So for the poorer parts of the population, what matters or what their wealth index depends on is basically the house construction and where they get the water from. Whereas in the upper part, the richer people, it's whether or not you have electricity, what type of toilet, what type of, if you have a landline telephone, if you have a refrigerator, if you have a radio, and if you have an iron, and so on. Have I got this mostly right? Mostly. It's not perfect, and I'll tell you why. So mostly yes, which is good for me. Anyway, I'll tell you why I'm saying this. It has problems. Why does it have problems? This technique is sensitive when you have attributes that co-vary. All right? It's ideal to apply it when you know that your attributes are not going to co-vary. So which are the attributes that co-vary here? Remember what we said in the beginning. This thing is going to come back to bite us. If you have electricity, you have refrigerator, right? If the base of the house is earth, you don't expect to find something heavy on the top, right? If you have a cement slab, then you can find a tin roof. Similarly, if your walls are made of wood, you don't expect to, or thatch or whatever, you don't expect to find a heavy roof. So these attributes are not entirely independent. If they were independent, fine, great, use this method without caution. But if they are dependent, then we've got problems. Then we have to start sieving. I don't need has electricity. I need has refrigerator because that's stronger. That's a stronger attribute. And that is the end if we want to drink some coffee. No, seriously, this is the end. All the code that generates all of these diagrams and all the models and everything is on this repository, which we can share. I have filled it with comments, okay, knowing that this might be accessed by other people than me, so I've gone very, very, very detailed on the comments. Don't be afraid of it. Most of it is plotting. All right? Don't feel scared that it goes on for pages. And the bit that does the modeling is this one. So, sorry, this one's the clustering. And then we come down to, this is Python, by the way, yes. So the idea here is I've got the data set with me in a USB stick. The idea would be that you start your Python distribution, whatever you have, Jupyter or whatever. I can give you the data, and what you can do is run this thing on the 2010 data. Or we can download the 2004, 2005, and then start making comparisons. Have life changed since 2004, 2005? And, or you can simply, have a go at exploring some of the questions we said. Why did I get the electricity wrong, for example? But keep in mind what is going to be the outcome of our next practical. We can reuse it in the data visualization. And in the data visualization, I will reuse these things. All right? So go get your tea and coffee. Sorry, are there any questions? I'm sorry, that was... All right? Anyway, even if you have any questions, just come and find me later on or send me an email and we'll take it from there, all right? Thank you very much for your patience.